Sharing data between threads is one thing, mutating it safely is another. The mutex keyword wraps your data in a log, so only one thread at a time can change it. The classic pattern is using arc with mutex. This allows us for the shared ownership plus safe mutation. Here we are trying to solve the race conditions. When we have multiple threads trying to modify the same piece of data at the same time, we can run into race condition, wherein the thread 1 reads the value, let's say 5, and before thread 1 can write its new value, the operating system pauses it and switches to thread 2. Thread 2 reads the value, which is still 5, and it increments the value by 1 and make it 6. Then the thread 1 resumes and calculates its own calculation, which is again the sum of 1, which is 5 plus 1, 6. So earlier the expected is that the value should have been 7 when the thread 1 and thread 2 ran successfully, and they both should have incremented the count by 1 and 1 each, and the value should have had become the number 7. But in reality, it remains 6, resulting into the race condition. Here is the example of a race condition. As we can see, we are running this loop 10 times and doing the incrementing the value 1000 times. So expectation is that we should have got 10,000 as an output, but we are getting 9719. If we run it multiple times, we'll get different values each time. This time we got 9549 and 9574. Now in order to solve it, we can use the classic pattern arc with mutex, which allows for the shared ownership plus safe mutation. Here each thread logs the mutex and increments the shared counter and unlocks when the guard goes out of scope. If another thread is holding the lock, it waits. We can use arc with mutex for global counters, caches, or shared state in multi-threaded apps. Just keep critical sections small to avoid contention.